Welcome to another video of capital budgeting. In this video, we will discuss another method used to rank projects and to decide whether or not they should be accepted for inclusion in the capital budget. This method is known as the net present value method, or NPV in short. The net present value method is a discounted cash flow technique which takes the time value of money into consideration. Let us consider an example to understand the steps needed to calculate the net present value. Assume that project X costs rupees 2500 now and is expected to generate year-end cash inflows of rupees 900, rupees 800, rupees 700, rupees 600 and rupees 500 in years 1 through 5. The opportunity cost of the capital may be assumed to be 10%. Find out the net present value of the project. So let us first depict this problem in the form of a time scale. So 0, 1, 2, 3, 4 and 5. Now the initial cash outflow is 2500. So we'll show this with a negative sign, that it is an outflow, so it is coming out of our pocket. And the cash inflow is 900, 800, 700, 600 and 500. The opportunity cost of capital is given as 10%. So basically this is the time value of money. So we need to discount the cash flows by 10% per annum in order to find the present value. So the first step in finding the net present value is to find the present value of each cash flow, including both inflows and outflows, discounted at the project's cost of capital. So here we have one outflow, but it is also possible that a project may need an outflow or some investment even for initial few years. So all those, whether it is outflow or inflow, has to be brought to the present value. So let's say the present value of the initial investment, which is 2500, is PV0. Let's say the present value of the cash inflow at the end of first year is PV1. Similarly, for the cash inflow at the end of second year, the present value will be PV2 and so on. Now we know that the formula for compound interest is A is equal to P into 1 plus I to the power n. Here A is the amount received at the end of the tenure, P is the amount which is invested at the beginning of the tenure, I is the interest rate per compounding period, and n is the number of compounding periods. Now A, as we mentioned, is the amount at the end of the tenure and P is the amount which is invested. So if we take this case, PV1 is the amount which if you invest today, then at an interest rate I of 10% and n of 1 year, the amount received will be 900. So A can be written as future value P can be written as present value into 1 plus I to the power n. So present value is equal to future value divided by 1 plus I to the power n. So now let's get back to the actual details of this problem. So here PV0 is minus 2500. PV1 will be equal to FV1 divided by 1 plus I to the power n1. So FV1 is 900 divided by 1 plus I is 10% or 10 divided by 100. So this is 0.1 to the power n1. Now this 900 rupees is at the end of first year. So 1 is the total number of compounding periods. So this is 900 divided by 1.1, which is equal to 818.18. Similarly, PV2 will be equal to FV2 divided by 1 plus I to the power n2. FV2 is 800. I is the same, 10%. N2 is 2 years. So 800 divided by 1.1 square. So this comes out to 661.16. Please note that I am rounding off these numbers to 2 decimal points. Similarly, if we continue, we'll find the values of PV3 as 525.9, PV4 as 409.8, and PV5 as 310.46. So let's now move to step number 2. Now the next step says sum the discounted cash flows. This sum is defined as the project's NPV. So here I have noted down all the present values that we had found in the previous step. So here what we have done is that we have notified the outgoing cash flow as negative and the incoming cash flow as positive. Now when we sum all these, basically we are subtracting the outgoing cash flow from the incoming cash flow, because incoming cash flow is positive while the outgoing is negative. And that is our net present value. So in our case, the net present value will be equal to PV0 plus PV1 plus PV2 plus PV3 plus PV4 plus PV5. So this becomes minus 2500 plus 818.18 plus 661.16 plus 525.9 plus 409.8 plus 310.46. Now again, these have been rounded off to 1 or 2 decimal points. So this comes out to be 225.5 rupees. So this is the net present value for this project. Now let's move to step number 3. Now step number 3 says that if the NPV is positive, the project should be accepted, while if the NPV is negative, it should be rejected. If two projects with positive NPVs are mutually exclusive, then the one with the higher NPV should be chosen. So if you recall, what we did was we made the cash outflows as negative and cash inflows as positive. So if we get a positive NPV value, what that means is that the inflow is more than the outflow. So if inflow is more than the outflow, that means the shareholders' wealth would increase and the project is going to be profitable. So if it is profitable, then the project should be accepted. Whereas if the NPV is negative, that means the outflow is more than the inflow. So what that means is that project is not profitable. So if the NPV is negative, it should be rejected. Now, there are sometimes projects which are mutually exclusive. That means either one of two projects can be done. For example, let's say that the IT department of a company says that they want to buy desktops for all employees or they want to buy laptops for all employees. So you will be evaluating one project as buying desktops for all employees, second project as buying laptops for all employees. So either one of the two projects will go through. You don't want to buy both a desktop and a laptop for the employees. So those projects are mutually exclusive. Now, if two projects with positive NPVs are mutually exclusive, so if both the projects have a positive NPV and you can choose only one, then what will you do? You will choose the one with the higher NPV. Why will you choose the one with the higher NPV? Because the one with the higher NPV means that it has more profitability than the other project. So in our case, we have a positive NPV. So if the criteria for choosing this project is that it should have a positive NPV, then this project should be accepted and it should go through. Now, sometimes you may get a value of 0 for NPV. So the value of 0 signifies that the project's cash flows are exactly sufficient to repay the invested capital. Or in other words, the cash outflow is equal to the cash inflow. The net present value or the NPV method is considered one of the most acceptable investment rule. It is the true measure of an investment's profitability.